Okay, so going over this quiz, look at the first one. The degree. The degree, remember this one's kind of weird. Some of y'all actually multiplied all this out. There's one person that your work was so beautiful and it was like this huge long thing. And I was so proud of you, but I'm sure it took you a really long time to do it and you didn't actually have to do that. So if it's not multiplied out like this, remember you can just add your two exponents together or three exponents or four exponents, however many exponents you had. So the exponent for the x plus 2 was 5. The exponent for the x minus 3 was 2. And you can do 5 plus 2 to get the exponent of 7. So your degree is 7. So like if you multiply this whole thing out, your first term would be negative 2x to the 7th plus blah, blah, blah. And it went on forever. Okay. So the degree was 7. The leading coefficient was that number at the beginning, negative 2. Because of that, we knew that it was an odd degree, negative leading coefficient. And so my end behavior looks like this. Rises to the left, falls to the right. You could just put arrows. You could write it out. It's up to you. And then the maximum number of turns was not how many times did it turn on the graph, but what is the maximum amount it can turn, which is the degree minus 1. So 7 minus 1 is 6. So the maximum number of turning points was 6. The next thing is what is the zeros, the multiplicity, and how does it affect the graph? So this x plus 2 to the 5th power, I did x plus 2 equals 0. I got x equals negative 2. It has a multiplicity of 5. 5 is an odd number, so that means it crosses the x-axis at this 0. So you had to have all three of those things for that 0. Over here, x minus 3 is to the 2nd power, so you got x equals 3 with a multiplicity of 2, which means 2 is an even number, so it means it touches and turns at that 0. Okay, so if you're just going to sketch your graph based off of this information, your graph should look something like this. At negative 2, it crosses through that. At 3, it touches and turns, and I knew my end behavior went up and down. If you actually graph this on a calculator, I think the y-intercept is like negative 576 or something. So obviously this would go way further down and then come way back up. And I based on some of y'all's graphs, I'm not going to type in your calculator. A lot of y'all like made it go down and then made a break and then made it come back up. We're just sketching it like based off of our information. So you didn't actually have to find the y-intercept. You didn't actually have to graph it. If I wanted you to do that, I would have made a graph that went all the way down to 576, or I would have picked an equation that had a better y-intercept. Okay. So this is just a sketch of it. You don't have to make it exact. I just need to use this information to get it on a graph. Does that make sense? Okay. Number 6, I was pretty happy with. The majority of you did this correctly. P's and Q's, the factors of P is 1 and 2. The factor of Q was 1, 2, and 4. You have to divide each P by Q. So 1 divided by 1 is 1. 1 divided by 2 is 1/2. 1 divided by 4 is 1/4. 2 divided by 1 is 2. 2 divided by 2 is 1, which is already there. You didn't need to do it again. 2 divided by 4 reduces to 1/2. It's already there. You don't need to do it again. Okay. Questions about anything on the front page? Okay, on the back page, remainder theorem to find f of negative 2. To use the remainder theorem means use synthetic division, divide, and the remainder is your answer. A lot of you tried to tell me like this is 2x to the 3rd minus 5x squared, like all that. I don't actually care what the answer, like what the division answer is. All we want to know is the remainder. Also, if you just plugged it in your formula, I'm not, sorry, your equation, I took off points because we're trying to use the remainder theorem here. Just use synthetic division and that's your answer. On number 8, this was the one that it was kind of crazy how some of y'all got your answers here. I told you that negative 2 is an answer. So negative 2 is one of your answers. Find the other ones. The way you find the other ones is you use synthetic division. Divide by the thing you know is the answer. You get a remainder of 0. This piece right here, x squared minus x minus 12, that is now a factorable equation. I could factor that into x minus 4, x plus 3 to get your 2 answers. Okay, so that's how you do that problem. And then the last one, long division. Some of the mistakes I saw, well, some people I just saw like an answer here and a bunch of work that didn't really match up. I don't know, like you figured out what the answer was and you just kind of scribbled some stuff on there. The biggest mistake I saw when I was looking through this though is, remember you do like, you write it up, you're like, how many times does 3x go into 3x cubed? It goes in x squared times. And so you do x squared times 3x to get 3x cubed, x squared times 1 to get x squared. And then you have to change both of your signs. Okay, a lot of people just made this subtraction and didn't even do that one and got 11x squared. And then you get fractions trying to do it. So make sure you change both of your signs when you do that. Questions about this? Okay, so make sure you look back at the thing I graded on D2L to make sure that you know what you did wrong so you can fix that in the future. I will post this on D2L. If you didn't actually do this, if you didn't turn it in, feel free to practice it. Print out a blank one, practice it, and see if you get the right answers. Like grade yourself on it, because this is what your exam looks like. Like I took exam questions and put them on this paper, and I will change the numbers for your exam. So if you can do this, you will be fine on your exam. Also, if you can do this in-class review we're going to do. Okay, so I tried to do, I did a few of the same ones, the ones that were commonly missed problems, and then I tried to do the ones that weren't on that practice one we just did. So if you put these two together, you have your exam. Okay, my goal is not to trick you here. Like I just want you to learn the material and be able to do it on the test. Okay, so let's go through this. We're going to go not super fast, but not super slow. We're going to try to get through it so we have a little bit of extra time to go over review questions from your other review. Again, if you're on Zoom, this is on D2L week 9. I just posted it this morning. Okay, so this is a problem just like the one we just did. State the degree. How do I find the degree? Add the two exponents here, right? X plus 2 to the 4th power, that tells me there are 4 of those answers. X minus 3 to the 5th power, that tells me there are 5 of those answers. So it is 4 plus 5 is 9 is the degree. The leading coefficient, what is the leading coefficient for this one? 3, it's just the number in front. If it didn't have a number in front there, what would your leading coefficient be? 1, right? Okay, so in behavior, odd degree, positive leading coefficient. Odd, positive, falls to the left and rises to the right. Are you recording again? Yes, Susie actually remembered to record it. Thank you for reminding me though. Maximum number of turns is degree minus 1. So the degree minus 1 would be 9 minus 1, which is 8. So this possibly could have a whole bunch of turns on it. It probably doesn't, but it could. Okay, find the zeros, multiplicity, and tell what it does on the graph. Okay, so x plus 2 to the 4th power, that is x plus 2 equals 0. When I solve, I get x equals -2. How many times is x equal -2 an answer? 4 times, because I have an exponent of 4. So it has a multiplicity of 4. 4 is an even number. Even multiplicity does 2 things. Because 2 is an even number. It does 2 things. Touches and turns. You could say that a different way. I think that's, or you could just say touches. You could say bounces. I don't really care what you say, just as long as you know that it's like not actually going through the x-axis there. So that is half of my answer here. The other half is the other set of zeros, x minus 3 to the 5th power. X minus 3 equals 0. So it is a solution at, or a 0 at 3. How many times is 3 an answer? 5 times. It has a multiplicity of 5. 5 is an odd number, so it only does one thing on the graph there. It crosses the x-axis. So I'm going to use that information to sketch my graph. I don't even need a calculator at this point. It's faster to do it without a calculator because it's going to take you a hot minute to type that in your calculator. Okay, so at -2, I'm going to put a dot there. It crosses my x-axis at -2. It also crosses at +3. My in behavior, it's going down on this side and up on this side, down to the left, up to the right. And it tells me it touches and turns at -2. So it's going to bounce here and come down. And then it's going to turn and come back up here somewhere. Okay. So the in behavior needs to go that way. Can you repeat that again on how you got that? Susie, on how I got what? The graph or the multiplicity stuff? Multiplicity. So the way you get the number is the number of times it is that answer is what multiplicity is. So like for this x plus 2, it had an exponent of 4. So it had a multiplicity of 4. It's the answer 4 times. If this is an even number, then it touches and turns. And then over here on x equals 3, it had an exponent of 5, so it had a multiplicity of 5. 5 is an odd number, so it crosses. Odd multiplicity crosses, even multiplicity touches and turns. And if you, just a second, let me get the paper out. I posted this last week on week 8. This is all the stuff you got to know. So I believe right here, multiplicity. You can make like little note cards out of this for your test. Okay. Okay, so number 6, possible rational roots. I think that's the same problem as before, right? So it'd have the same answers as the one we did just a minute ago. Is it the exact same problem? No. Yep, look at that. I just copied and pasted it. It's the same exact problem. So that's the answer for that one. We're not going to spend our time on that one. We're going to move on to the other problems. Okay, look at the back. Quadratics. It's been a little bit since we did quadratics. Remember, there are 2 different types of forms for quadratics. This is like the vertex form. This is the standard or general form, depending on what book you're talking about. Okay, so look at number 7. Does that first quadratic open up or down? Can we use the note cards on the test? No, that was just to try to help you to study and memorize for your test. Okay, so does this quadratic open up or down? Up. How can you tell it opens up? Yeah. The leading coefficient is positive. In this case, we call that the a value, I believe. A times x minus h squared plus k. So a is positive. You can say leading coefficient is positive. You can say 2 is positive. I don't really care how you say it. Just tell me that positive goes up. Josue, no, there's no definition on the test. Your test looks just like these papers. Okay, does this have a minimum point or a maximum point? If it opens up, yeah, if it opens up, it has a bottom point, a minimum point. And what is the minimum point? Yeah, the name of this is the vertex. So I'm looking for the vertex here. How do you find the vertex when your equation looks like this? It's the h and the k, right? So hk, what's my h value? 3. What's my k value? -2. When it's in this form, everything's just like there for you. You don't have to do math to figure it out. It's just, you have to know where to find it at, essentially. Axis of symmetry. It's that vertical line that goes through the vertex. So since it goes through the vertex, does it use the x part of the vertex or the y part of the vertex? The x part of the vertex. So it is x equals your h value, which is 3. And this is all on that sheet. Remember, axis of symmetry, vertex, all of it's there. Okay, so that's the pretty easy one to do. This next one's a little bit more difficult. How do I know if this one opens up or down? It opens up. The a value in this case, yep, it's still ax squared plus bx plus c. So it opens up, and we know that because a is still positive in this case. Okay, so since it opens up, does it have a minimum or a maximum? Minimum. I need to find that point, the vertex. This one's a little bit more difficult to find because it's not just in my equation that I just look at it and tell me. I have to find the axis of symmetry first. Do you remember how to find the axis of symmetry? X equals -b over 2a. So -b over 2a. And I need to get, sorry, I was trying to think how to figure that out. B is the number in your equation, the 4. So it's -4 over 2 times my a value is 1. So -4 divided by 2 is -2. So my axis of symmetry is x equals -2. Okay, so that tells me part of my vertex. What part of my vertex does it tell me? The x value of my vertex. How in the world am I going to find a y value? plug in x into my equation. Don't I have an equation and part of the answer? Yeah, plug it in. F of -2 equals -2 squared plus 4 times -2 minus 12. Let's see, this is 4. This is -8 minus 12. Should be -20, which would be -16. Is that what you got? I feel like that's kind of big. Is that right? Check my math. Plus 4 minus 12. That's right. Okay. I usually try to make it fit on the graph. That's not going to fit on the graph. Whatever. So then to find the x-intercepts, how do I find the x-intercepts? Yeah, that's right. How do you find x-intercepts? Set y equal to 0 and solve. X squared plus 4x minus 12. That's a quadratic. There are multiple ways to solve that. The easiest way would be factoring or quadratic formula. What do you want to do? Factor. It factors into two things that multiply to get 12, add to get 4, or -12, add to get 4. It'd be 6 and 2. Which one needs to be negative, the 4 or the 2? The 2 needs to be negative. The 6 is positive. Set those equal to 0 and solve. X plus 6 equals 0. X minus 2 equals 0. So I get -6, positive 2. So -6 and positive 2 are my x-intercepts. And how do you find the y-intercept? Plug in 0 for x. So 0 squared plus 4 times 0 minus 12 is -12. Okay, let's graph it now. The axis of symmetry is at x equals -2. So -2, I'm going to have a vertical line going through that point. The vertex is at -2, -16, which is going to be, I'm going to put it right down here. I'm going to say that's -2, -16. On your test, it will be on the graph. I will double check or I'll make your graph bigger. Your x-intercepts are -6 and +2. Do those look like they're in the right spot? Is the axis of symmetry right in the middle of them? Yeah. If your axis of symmetry is not in the middle, you did something wrong somewhere. Either your intercepts are wrong or your axis of symmetry is wrong and your vertex is wrong. So double check and make sure it all matches up. And then my y-intercept is at -12, which would be right here. I can draw my parabola from that. It looks something like this. Questions about that? Okay, that's everything you could possibly have about a quadratic right there. So make sure you know how to do those. Look at the next page. This is the rational functions that we did last time. There's a lot of information you need to know to be able to do this, but the actual math isn't that hard. Vertical asymptote. How do I find a vertical asymptote? Set the bottom equal to 0. So x minus 2, oh, that's supposed to be a 2. X minus 2 equals 0. So x equals +2. That's the vertical asymptote. Where do I draw a vertical asymptote on my graph at? Or what does it look like on my graph? A vertical line, right, on your graph. And it's going to be at 2. I'm going to do a dotted red line. Feel free to bring colors and use colors on your test if you want to. How do I find a horizontal asymptote? Sorry, I'll give you a second to catch up. Okay, so horizontal asymptote. How do you find a horizontal asymptote? Yeah. It's the Bobo Botan eats DC. So you need to know degree on top and degree on bottom. What's the degree on top? 1. What's the degree on bottom? 1. Is it bigger on bottom? No. Is it bigger on top? No. So exponents are the same because the degree is the same. So we divide your leading coefficients. That's what the DC stands for, divide coefficients. So it's y equals, what's the leading coefficient on top? 3. What's the leading coefficient on bottom? 1. So y equals 3 is your horizontal asymptote. So on my graph, I'm going to put a horizontal line at y equals 3. Do we have a horizontal asymptote? Yes. So do we have a slant asymptote? No, you will never have both. How do I find x-intercepts? Technically, you could set the whole thing equal to 0, but your first step is to multiply by the denominator, and you end up with just the top equal to 0 or the numerator equal to 0. So 3x plus 6 equals 0. Subtract 6 divided by 3. Negative 6 divided by 3 is negative 2. Is your x-intercept? You can go ahead and plot that on your graph at negative 2. It crosses the x-axis. Y-intercept, how do you find a y-intercept? Plug in 0 for x, solve for y. 3 times 0 plus 6 over 0 minus 2. That is 6 over negative 2, which is negative 3. So I have a y-intercept of negative 3. So let me plot that on my y-axis. If you are comfortable with graphing these, if you've had like a decent amount of experience, that's probably enough to graph that. If this is like brand new and you're like, I don't even know how to make a graph out of that, how could you get more points for that? I'm sorry, this is enough points to graph this side of the graph. It is not, there are no points to graph over here. But like for me, I've been doing this for a while, so I could probably draw a graph out of this. I know that it's going to get close to my red line over here, and it's going to curve and get close to my red line over here. If that's something that you're not familiar with, how could you get more points over here on the left-hand side? We could make some test points over here. That's why I say if needed. You're probably going to need them, but you may only need 2 of them, whereas somebody else might need 6 of them. It just depends on how much time you have spent graphing these. Okay, so I need to put this graph in my calculator. Do not forget parentheses 3x plus 6 on top divided by parentheses x minus 2 on bottom. Again, if you have problems putting things in your calculator or getting information from your calculator, I can answer those questions on your test. I can't answer, how do I graph this? Okay, I can answer calculator questions. Okay, so you go to your table of values. Mine is still like this from last time, where I need to type in numbers. You could still type in numbers here. Let's say you don't want it. You want your regular graph to look at, the regular table of values. How do I fix that? 2 ways to fix it. Yeah, the way to actually fix it is you actually go to table set, so second table set, and then the independent needs to be an automatic instead of ask. It was asking me, so I put in whatever. I can go back to my table. Let's say you don't remember that. You can raise your hand and I can help you with that, or you can always clear your memory. If your calculator ever messes up, clear the memory, it sets it back to normal, and then you should be good from there on out. Okay, so what numbers do I want to pick from here? I already have x value of negative 2 and x value of 0. So what else would I pick here? Whatever you feel like you're missing. Do you feel like you're missing something over here? Sure, let's pick negative 5. Do you want to figure out at positive 1 to see where that's at? Sure, so pick positive 1. At negative 5, it is at 1.3. At positive 1, it is at negative 9. So at negative 5, it is at 1.3. At positive 1, it is at negative 9. Is that enough to graph for you now? Sure. So draw your graph. You can see that it is a curved line that is approaching your red lines on that side. I need some numbers on the other side because I have no points over here. I would not pick the x value of 2. Why would I not pick the x value of 2? It's on the vertical asymptote and your calculator says error. There's no graph there. It does not exist at that point. Okay, so let's pick the x value of 3, 4, and 5. And that should tell us pretty much what's happening over there. At 3, it's at 15. At 4, it's at 9. At 5, it's at 7. Oh, second quit. You may want, since 15 is on your graph, you may want to have it at 6. It's at 6. Okay, so I'm graphing at 4, it's at positive 9. At 5, it's at positive 7. At 6, it's at positive 6. Do you see what's happening on this side of your graph? If that's not enough points and the answer is no, get some more points and put some more points on your graph. If the answer is yes, then go ahead and graph it. And you should be able to check your graph with your calculator. Does it look about the same? Yeah. Questions about that? Okay, flip it over on the back. Last little bit. So for this, we're not actually graphing this. I just want to know the asymptotes here. I want to know the vertical asymptote, the horizontal asymptote, and the slant asymptote. One of the answers is going to be what? None. Because can you have a horizontal or a slant? No, you're not going to fill in answers for all 3 of these. One of them is going to say none. Okay, we need to figure out which one. Vertical, how do I find vertical asymptote? Set the bottom equal to 0. X minus 3 equals 0. X equals 3. Check. Done. Horizontal, it's either Bobo, Botan, or Eats DC. What is the degree on top of this one? 2. What's the degree on bottom? 1. Is it bigger on bottom? No. Is it bigger on top? Yes. What does the N stand for? None. So this does not have a horizontal asymptote. So that tells me it has a slant asymptote. Everybody good with that? Okay, so now to find the slant asymptote, I have to divide it. Top divided by bottom. The answer of this is going to be in the form of y equals mx plus b. I need to figure out the m and the b. The way I figure that out is by doing long division or synthetic division. In this case, can I use synthetic division? Yes, because I'm dividing by x minus 3. So what I'm going to do is I'm going to do x squared minus 4x minus 5, and I'm going to divide it by x minus 3. So I'm going to use synthetic division. What am I going to divide by? What number? Positive 3. You divide by the root. The numbers I'm putting in is a 1, negative 4, negative 5. Remainder's under negative 5. Remember, I don't care about the remainder. So bring down the 1. 3 times 1 is 3. Negative 4 plus 3 is negative 1. You could keep on going. 3 times negative 1 is negative 3. And I get a remainder of negative 8, but I don't need that. All I need is those 2 numbers. That's my m and my b. So what is my equation of my slant asymptote in this problem? Y equals 1x minus 1. You could just put x minus 1. You don't have to put the 1 there if you don't want to. Okay, so this is the M, this is the B. Questions about that? Okay, so last time we went over one of these problems. I said I was going to post a video. I went to go record the video and somebody was using the studio that we record in. So I didn't, did she get 3 from 3 minus 3? The way I got 3 was the thing you divide by, you set it equal to 0 and solve. So that we, on synthetic division, we use the root here, not the factor. Does that help, Alicia? Okay. Okay, so I couldn't make my own video, so I just found one online. He did it the same way as I did it, but you may not have liked it. So let's go ahead and go over this. So to solve an inequality, what you have to do, essentially what I'm doing here is this graph of x plus 7, x plus 2 is a graph that looks like this. It's a quadratic that looks something like that. And the question is asking, where is this less than or equal to 0? Okay, so it's asking, where is this graph? Just a second, Josue. Where is this graph negative at? Okay, the graph is negative under the x-axis, this piece right here, right? So the question here is asking, where is this graph negative? Where is it under the x-axis? You write this piece in interval notation. Okay, sometimes they're not quite so easy just to look at the graph and do it. So the way to do it a little bit easier is to use some test points. Okay, the graph changes from above the x-axis to below the x-axis at the x-intercepts. Would everybody agree? That's where the changing point occurs, is it goes through the x-axis. So the first thing we do is find the x-intercepts. Okay, so when we find the x-intercepts, this is a nice problem because it's already factored for you. X plus 7 equals 0. X plus 2 equals 0. Solve it, you get -7, -2 for your answers. Okay, so those are the changing points at the x value of -7, at the x value of -2. I'm going to go ahead and put those on a number line. I have -7 here. I have -2 here. Okay, so these are the changing points. That means I have 3 different intervals for my graph here. This first interval right here is the interval from -infinity to -7. This middle interval is from -7 to -2. And this last interval is from -2 to infinity, right? The way we decide if we're using parentheses or brackets, infinities always have parentheses on them. How do I decide if I'm using parentheses or brackets for the other stuff? Yeah.
Well, if it's less than or equal to,
Mm-hmm. In this case, I'm doing equal to, so I'm going to use a bracket. Okay, so some of these are my answer. It could be one of them. It could be 2 of them. It could be all 3 of them. It just depends on the problem. Okay. The way we figure out which one of them is the answer is I'm going to pick a test point in that interval and plug it in essentially to my equation and see, is it less than or equal to 0? What kind of numbers are less than or equal to 0? 0 is equal to 0, yes. But what kind of numbers are less than? Negative numbers. So I'm going to plug it in and I'm looking for negative numbers here. I don't care what the number is. It could be 100, it could be 1,000, it could be 1,000,000. I don't care. I just want to know, is it negative or positive? Okay, so let's pick a test point in this interval from -infinity to -7. I'm not going to pick -7 because the answer is 0 there because it's an x-intercept. So let's pick a number other than -7 in this interval. What number do you want to pick? -10, sure. It doesn't matter. Pick any number you want to. Pick the easiest one sometimes is the best way to do it. So if I pick -10, I want to figure out when I plug this in, do I get a positive or negative number? Again, I don't care what the number is, just positive or negative is all I want to know. When I plug in -10 into my equation, x plus 7, what do I get? -10 plus 7, is that a positive or a negative number? It's a negative number. It's actually -3, but I don't care about the 3. All I care about is the negative. When I plug it into this part of the equation, -10 plus 2, is that a positive or a negative number? A negative number. So when I get a negative number and I multiply it by a negative number, what kind of number do I get? A positive number. Okay, again, you could have it as -3 and -8, and -3 times -8 is positive 24. We're trying to take out the mathy part of it. All I care about is the signs here. So that tells me that the graph is positive here, which we saw over here. It's above the x-axis. Is this part of my answer? No, because I want to know, where is it negative? Okay, so let's pick the middle part. When I pick the middle part, pick a number in between -7 and -2. Don't pick -7 or -2. -6, -5, it doesn't matter. Pick one of them. I'm gonna pick -5. I'm gonna do the same thing again. I'm gonna plug it into my problem. I don't care about the answers. You could do it if you want to. All I care about is the sign. When I plug in -5 to x plus 7, Is it a positive or a negative number? Positive 2. Yeah, it's actually positive 2, but just a positive number. When I plug in negative 5 here, negative 5 plus 2, is that a positive or a negative number? It's a negative 3, a negative number. What is a positive number times a negative number? It's a negative number. Okay, is that the part of my graph that I want? Yes, because I wanted negative numbers. Okay, that's this part underneath the x-axis. Over here, pick a test value over here, a number between -2 and infinity. We'll pick 0 because it's the easiest one to pick there. When I plug in 0, 0 plus 7, is that a positive or a negative number? Positive. When I plug in 0 plus 2, a positive. What's a positive times positive? Positive. That's this piece over here, right? Those are the two positives. This is the negative down underneath it. Do I want positive numbers? I do not want positive numbers. I only want negative numbers. So my answer is that interval, -7 to -2. A few tips about these problems. Usually, in most cases, they flip back and forth, positive, negative, positive, negative, positive, negative, okay? There are some cases where they don't. If you kind of think about polynomials, when we have an even multiplicity, it bounces off the x-intercept and then turns back down. So in that case, if you had an even multiplicity for one of your x-intercepts, it'd bounce and turn, it'd be negative, negative in that case. Okay, so just kind of a heads up, usually they're switching back and forth, but that's not always the case. Does this make sense, how to do this? Okay, and you can kind of check it with your graph. If you type that in your graph, you can look. If this was a greater than or equal to sign, let's pretend like it's a different problem. And so this is the answer for the less than or equal to. What if it was greater than or equal to? What would my answers be? The first and last. I have two pieces that are above the x-axis. It'd be -infinity to -7 and, or union, -2 to infinity. If it was just less than, not equal to, how would this answer change? It'd just be a parenthesis instead of a bracket. If it was just greater than, not equal to, what would my answer be over here? Just parentheses, not a bracket. Does that make sense? Okay, you good with those now? Okay, we have 8 minutes left. That's not a whole bunch of time, but we have a review that you may have questions over. We've gone over a problem similar to everyone on the review today in class, but I'm happy to answer any questions you have on this, and I will post the answers for this, the solutions for this review on D2L this afternoon. Megan says number 5. Since we only have 8 minutes, if I tell you that number 5 is not on the test, do you still want to go over it, Megan? Okay, I'm happy to go over it, but I just want to be useful with your time right now. What else? Same thing with number 6. Look at number 20. Let's do that one. So this is the problem where I give you an answer and you find, let me get some new paper. You find the other answers on number 20. There we go. So for number 20, you're given the problem of 2x to the third power minus 13x squared plus 17x plus 12 equals 0. And we are told that x equals 4 is an answer. I'm trying to find the other answers. So how many answers does this problem have? 3 answers. One of them is 4. I need to find the other ones. So we need to divide by 4 using synthetic division. You could use long division if you wanted to. Synthetic's faster. And when I use synthetic division, I should get a remainder of 0 because 4 is a 0. It is a solution to this problem. So bring down the 2. 4 times 2 is 8. -13 and 8 is -5. 4 times -5 is -20. 17 and -20 is -3. 4 times -3 is -12. 12 and -12 is 0. So that tells me that x equals 4 is a solution. It also tells me that this equation factors into x minus 4 times this leftover stuff, 2x squared minus 5x minus 3. So here's one of my answers, x equals 4. My other two answers are in this piece. How do I find the other two answers? Either factor using the AC method, or if it didn't factor, how else could you find it? Quadratic formula. I'm pretty sure this factors. If you do the AC method, A is 2, B is -5, C is -3, AC is -6. That would be -6, +1. So this is 2x squared minus 6x plus 1x minus 3. Factor by grouping. This is 2x times x minus 3. And there's not a GCF here, so I'm just going to pull out a 1 times x minus 3. So it factors into x minus 3 times 2x plus 1. I want to bring down the x minus 4 factor. So here's the factors. How do I find my solutions? Set all your factors equal to 0. So when I do x minus 4 equals 0, I get 4. I've known that one all along. X minus 3 equals 0, I get 3. 2x plus 1 equals 0. Subtract the 1, divide by 2. I get -1/2 as my answer. So there are your 3 solutions. What else? You want to do another inequality one, 29 or 30? Are you good with those? We got time for one more problem. Anything else? 30. Josue wants to do 30. Josue, did you get the eats DC part? No. Okay. Let me go back to that real fast. So when you are doing, that's not it. When you're doing horizontal asymptotes, I got it somewhere. Let's see. Here we go. When you're doing horizontal asymptotes, you're looking at the degree on top and the degree on bottom. The degree on top of this one is 1. The degree on bottom of this one's on 1 is 1. So we have 3 options. It could be BOBO, and that's bigger on bottom. The O tells you that your horizontal asymptote is y equals 0. Bottom, this is bigger on top, and the N stands for none. And the eats DC, that's my only other option, is either bigger on bottom, bigger on top, or the same. This is exponents are the same. So this is when the degree is the same on top and on bottom. And DC, this means divide your coefficients. And it's actually the leading coefficient. So the leading coefficient here was 3. Leading coefficient on bottom was 1. So I did 3 divided by 1 to get 3. And that's my horizontal asymptote. Does that help? Okay, so for this one, this is a quadratic, same type of problem, just trying to figure out if it's greater than or equal to 0. First thing I have to do is factor it, okay? The problem number 29 was already factored for you. This one's not factored. If you spend the time on it and you factor it, you get, it factors into x plus 5, x minus 3 is greater than or equal to 0. So then you're going to find your x-intercepts, set both your factors equal to 0 and solve, and I get -5 and +3. So on my number line, I have -5, I have +3. These are the changing points, the turning points of my graph, okay? So like my answer could be some of these, or some of the intervals. It could be 1, it could be 2, it could be 3. Okay, so this interval is negative infinity to negative 5. And the negative 5, is it included or not included? Not included because I'm not using equal to. It could also be negative 5 to negative 3, positive 3, excuse me, or it could be 3 to infinity. Those are my options. To figure out which option it is, let's pick a test point. I'm picking a test point in between negative infinity to negative 5. I'm going to pick negative 6. Let me do this in a different color. I'm going to pick negative 6. When I plug in negative 6, all I want to know is it negative or positive. What am I looking for here? Greater than 0. So I want positive numbers here. Okay, so when I plug in negative 6, plug it back into your factors. You could plug it into the initial one, but that's a lot more work. It's a lot easier to plug it in the factor part. Negative 6 plus 5 is a negative number. Negative 6 minus 3, that's also a negative number. What's a negative times a negative? Positive. That is part of my answer. Let's check the next one. Pick a number between negative 5 and 3. I'm going to pick 0. When I plug in 0, 0 plus 5 is a positive number. 0 minus 3 is a negative number. Positive times negative is a negative. Is that part of my answer? No. Over here in this part, a number between 3 and infinity, I'm going to pick 4. If I plug in 4, 4 plus 5 is a positive number. 4 minus 3 is a positive number. What's positive times positive? Positive. So that's part of my answer too. So my answer is negative infinity to negative 5, union 3 to infinity. Okay, so Sonia asked, do we turn in the review for extra credit? Yes. If you have it on Friday, no, Wednesday, all of it worked out, just turn it in and I'll give you 5 bonus points on your exam. Not the ones we did in class, this review right here. Okay, you also have a review on D2L with Math Excel. Make sure you're working on all of that and make sure you are here in class on Wednesday for your exam. Let me know if you have any questions. Yeah, you know this one. Not paying attention. Let's see.